Yeah, are we ready? Can we start?
Rachit, I think you're muted.
Yeah.
Okay, sure.
Yeah, we have started the stream as well, so I think we can start now.
Okay. So, hi everyone. I am Arushi Abrol and I welcome you all to the workshop, An Introduction to Blockchain by Rachit Bhaiya, a proud alumni at JDSC TIT, who is currently a solidity developer at Nethermind and is having a great experience in this field of blockchain. So, over to you, Bhaiya.
Can you enable screen sharing for me?
Co-host बना दे आरुषि.
Bhaiya, kindly check, are you able to do so now?
दो हैं रचित
Now it
श्रीवास्तव
is,
पे
I guess.
No. So let's start then. Hello guys, I'm Rachit, alumni of DSC TIT and also just completed my final year examination. And I've been working in the blockchain space for around 3 years and started my career with Harmony One blockchain. And then later started working with Nethermind and also been an active contributor to some NFT projects like Fortium Atlantis, and till date have helped my smart contracts of the mainnet have done around $5 to $6 million in transactions. So what is a blockchain? So a blockchain is nothing but a bunch of computers working together to reach to follow a particular consensus. So just imagine that I cannot write using my iPad. Can you guys check?
We actually cannot see your iPad right now.
Yeah.
Okay, let me retry. I still cannot write.
If you're using an iPad, you can use Sidecar and then stream the screen of your iPad.
Yeah, I need to disable then the screen with sharing here. It's fine. Let's just continue. Blockchain is what is a blockchain? Blockchain is basically a bunch of computers spread all around the world, which are interconnected to each other in a peer-to-peer manner. And what they do is follow a consensus, which we will call later, but it is basically a set of rules. And using that set of rules, they process a bunch of transactions and add it to the blockchain. Adding to the blockchain means nothing but adding an additional block to a bunch of blocks connected together. And this addition is like an immutable event and it cannot be further done, further be modified. So basically, the nodes are responsible for making sure that the security and the validity of the blocks are intact and there is no malicious activity on there. So what is actually a consensus? Consensus, as I stated, is a bunch of rules that are followed by the nodes to create this distributed ledger. So there are several types of different consensus mechanism. We will only be covering POS and POW, which are the most widely spread used and most in demand, you can say. So proof of work, let's first cover proof of work. So proof of work is basically the first mechanism that was introduced to us. And this was introduced in 2009 with the introduction of Bitcoin blockchain. What proof of work basically does is there is a bunch of machines and there is a one particular very super complicated mathematical function that needs to be solved. Once that mathematical function gets solved, the transaction is considered to be mined. Basically the entire concept of proof of work is all of these different nodes will fight with each other to complete this mathematical computation foremost, and whoever does it transit it to the entire network. If the block gets verified, the miner who solved the mathematics got rewarded. So this is the mechanism used in Bitcoin, for instance. The miner gets rewarded in Bitcoin. POS is basically proof of stake. So there are a bunch of nodes, and these nodes usually are referred here as validators. And what the entire concept is, there are a lot of people who will stake their tokens. So there is a validator who can have a particular value assigned to them. This value is basically the number of tokens that a validator owns. And based on this, they are assigned if they will be elected or not to validate a block. So to better understand it, there is a validator A and there is a validator B. Validator A has more number of tokens with it compared to validator B. So now when the validator is selected, when a transaction has to be mined, the validator needs to be selected. The algorithm will prioritize validator A because it has more number of tokens. So it will have more chances of mining the block and adding it to the blockchain. So that is the entire concept of POS. So the higher the value you have of the number of native tokens, the higher the probability of you getting elected is. And POS and POW are relatively pretty secure, but if you think about it, POW is vulnerable to 51% attack because let's say if there are 10 nodes, you just need to control, let's say 6 of them. And in POS, you need to control 51% of the entire value of the value of that cryptocurrency. If there is a million Ethereum in supply, you have to have at least 500,000 Ethereum to control POS. So in that sense, POS is actually more secure than POW. So these are the two main ones. There are others for example, another popular implementation is proof of history followed by Solana. But there is this thing called blockchain trilemma that we will cover in next slides. And that's where Solana's proof of history kind of doesn't work that well. So let's first discuss what blockchain trilemma is. So blockchain trilemma basically states that decentralization, scalability, and security, all three things cannot be achieved at the same time. So either you can have security or speed, either you can have decentralization or speed, or you can have security of decentralization. So for example, if you take example of Solana, so Solana takes like its main priority is speed, but at the same time, it isn't that decentralized. Same case with Polygon. It is not that decentralized, it's pretty centralized, but it offers speed and security. Contrary to Ethereum, Ethereum is secure and decentralized, but it is not fast, as we all know. So this is like the trilemma we try to deal with. Solana actually cannot be said that it is not fully decentralized. It is kind of a mixture of both, but the consensus is highly unstable. So if you have been in touch with the Solana ecosystem, Solana blockchain goes down like twice a month. And it's because of the complex consensus that we are trying to use, but it's not at all stable. So the trilemma is still holding. So since if you take if you talk about importance, security and decentralization are more important than speed in our terms, but to achieve speed, that is we need scalability for the blockchain. We have several scaling solutions. So some of these scaling solutions are Zk rollups, optimistic rollups, and sharding. So firstly, let me just try to explain what a rollup itself is. So rollup is something you can just think of it that you have a bunch of transactions with you and you try to roll them up and put it in the blockchain. That's literally what we are doing when we talk about rollups. So it's like instead of doing 5 different transactions, you just input one with the data of those 5 to roll together and put into the blockchain. So if we talk about some scaling solutions, it will become much more clearer how it is working. So for example, ZK rollups is basically a rollup in which we utilize a cryptography called zero knowledge proof. So firstly, what is zero knowledge proof? So zero knowledge proof is, you can think of there are 10 people and you have to vote on something, either yes or no. So you all voted, you will have the final result that there are 6 yes votes, there are 4 no votes, but you will not know who the individual voter was and what the individual voter voted for. So in that way, you have the anonymity, but you have the correct verified cryptographic proof of what the final result is. So that is what zero knowledge basically means. So one of the so zk snark is also like a scaling solution for Ethereum, and it utilizes zero knowledge proof. So what did these computers do? You send the transaction to Ethereum. This transaction is all the transactions are done on mainnet. When we talk about true layer 2 scaling, and whenever you send a transaction to a mainnet, this transaction is not processed by the nodes of the Ethereum blockchain, but are actually processed by off-chain on a separate computer. And what these computers are basically doing is aggregating such transactions together. And once these transactions are aggregated, these are passed and added back to the blockchain in as data. So what's the difference between data and transaction? So an Ethereum blockchain has transactions inside of it and a section called data. So these are actually utilizing this data and passing the proof of the transactions being validated inside this data field. So that is what zk rollups are actually doing. This data that is added back to the Ethereum blockchain by these zk rollup machines is actually cross-verifiable because of using zk, that is zero knowledge cryptography. This is zk rollup. Secondly comes to optimistic rollup. Optimistic rollup is similar to zk rollup, but just we remove the part in which we have we mathematically verify transactions on chain also. Optimistic rollup, as the name states, is a bit optimistic. We believe that whatever the data is given to us is correct. So there is a point of centralization also here. So in optimistic rollup, currently the best implementation of this is optimism. So what they do is basically they aggregate a bunch of transactions together, and there are a bunch of validators which finally put that transactions back into the Ethereum mainnet, similar to how it works in zk. The only difference is this data now that is finalized and put it in the Ethereum blockchain is not cannot be verified backwards. So we basically assume that whatever the data is inputted on the blockchain mainnet, that is layer 1, is actually correct and verified. We basically trust the validators who are inputting that data. The data that is inputted can be questioned in between these optimistic rollup machines. So they can interact between each other and do the verification if it is correct or not. But once it is added to the mainnet, it cannot be cross-verified backward. And then we come to the third scaling solution, which is sharding. So sharding basically refers to the concept in which it's also a concept which will be used by the Ethereum 2.0, and there are some chains like Harmony that are already using it. So sharding is basically there is a single chain that you do transactions on. Instead of single chains, you create multiple parallel chains, and then there is a central chain. So central chain is usually called the beacon chain. So these you can do transaction on these parallel chains, and once the transaction gets done, the messaging of these parallel chains is done using the beacon chain. So we basically take a blockchain, we divide it into multiple parallel blockchains, and then we have a central blockchain which helps in communicating between these blockchains. That is the entire concept of sharding. There are some other solutions also, for example, sidechain, which currently what Polygon is. So sidechain is basically a chain which is running in parallel, but it in itself is also a blockchain. So its security is not defined by layer 1, unlike the zk rollups and optimistic rollups we covered. Also, there are one or two more, but I think for this scope of the workshop, we are just taking the main ones which are right now into consideration when it comes to scaling. So smart contracts. So what are smart contracts? So initially, when the blockchain ecosystem was launched using Bitcoin blockchain, all we can do is actually hold these tokens called Bitcoin and send it to someone else, receive it at the point, and like that's basically it. You cannot actually do anything much with it. You cannot go around and earn interest on it, or you cannot have things like NFTs on it. So in 2015, when Ethereum got launched, a new concept was introduced, which was called the smart contracts. And what it basically is doing is In this new blockchain, there is basically a language in which you can run code. So not only are you just doing normal transactions, you can do transactions which will execute a particular set of instructions. And these instructions are basically called as smart contracts. They can be written in Solidity, Viper, and Cairo. I will cover Cairo a bit later. And Solidity, Viper are the main ones that are widely used in EVM compatible blockchain, that is Ethereum virtual machines. Ethereum virtual machine, simple job. You deploy a smart contract, it has the code for it, and now you can make transactions that can perform a specific task, a task specific to that code base, simply. So Solidity, Viper are currently most widely used. Among those two also, Solidity is always mostly the preference. Cairo is a new language that is introduced recently. It is pretty new, and there is a scaling solution called StarkNet, which is like probably one of the most like the optimistic role. It is the scaling solution on which almost everybody is bullish on, because it offers a lot more than what ZK Sync is offering. ZK Sync is ZK rollups are offering. They are not only integrating ZK rollups, but they are also offering a lot of new things. For example, on-chain verification of signatures and stuff like that, which is not inherently available in EVM. So Cairo is the language which will be used on StarkNet, and it is also like widely getting adopted slowly in the ecosystem, though it is still in a very new stage and still in the development stage. But maybe something which might replace Solidity in the long term. Small chance, but yes. So here is a small code of Solidity, but I think we can go through a proper ERC20 code later on in this workshop to actually understand how Solidity code is written. So now let's come to decentralized finance, which is probably one of the best application of smart contracts and blockchain in real life. So initially Bitcoin was introduced in which, and Bitcoin offered you basically stuff like you can own your own money. You don't have to rely on some bank and stuff. And you basically are now the actual owner. Like if you actually go to a bank and you deposit your money, you are actually giving them the ownership of your money, and they are just acting as a custodial for your money. That's all they are doing. So they actually have the rights to do whatever they want with your money. So it actually happens in the real world that the bank takes your money, they lend it out to someone else, and then they sometimes they don't have enough money now to pay you back. So this is a thing called bank run, which used to happen in the past a lot. And then there are some financial terms also, for example, fractional reserve, which are used in banks. So basically, if you have like a bank has, let's say, $1 million, so it has to keep a minimum deposit of 10%, let's say $100,000 for withdrawal. Those are kind of things exist, but you don't have entire 1 million because they have either lended that out, or they are either using it in forex trading or trying to do different kind of trades, which at certain degree is a bit risky. And you don't have actually control over it because you don't have the custody. What blockchain is actually giving you is giving you back the power of control of your own money. And this is what basically the Bitcoin introduced, but it was very limited because, let's be honest, you just are holding a coin and you cannot do anything else with it. So that's why the introduction of smart contract changed the game. And the foremost industry that was introduced was decentralized finance. So now, if you have your money in your cryptocurrency, you can do whatever you want with your money. You can earn interest, you can stake it, you can provide liquidity, you can act as a market maker in a way by providing liquidity, and you can basically design your own investment strategies and a lot of different solutions. So that was something we were able to achieve using decentralized finance. So I'll just cover some of the most popular implementations of it. So if we talk about decentralized applications, one of the most popular implementation is clearly Uniswap. So what is Uniswap? It is nothing but a protocol on which you can exchange currencies in a decentralized manner. So right now, if you, let's say, want to buy a stock or want to buy a crypto, or interchange between any stocks or crypto, you have to go to a central exchange. They will see your order, check your order, and then do the transactions. Here, there is a middleman involved, right? In Uniswap, you don't need a middleman. There is simply a mathematical equation, which is x into y equals to constant. And what it does is basically there is like, it's very hard for me to explain without a pen right now. So apologies for that. But there is a x by y equals to constant relationship. So if you withdraw a lot of x, then the value of the amount of y increases. So the value of y goes down, if it makes sense. There is the demand for x, and there is excess supply of y. So the graph shifts a bit. It might be very hard for me to right now cover it without a pen. So, but it's basically done in a decentralized manner using mathematics. Similar cases with another popular protocol, which is Aave. So Aave, what you can do, you can go and put in your money there, and then there is someone else who can come and borrow money from there, and they will pay an interest. So the borrower is paying, let's say, 10% interest. So you get like whatever the money the protocol is earning from the borrower, you get that money as an interest in a way. So it is similar to how a bank works. The only difference is you know where your money is, and you can see that everything in a transparent manner on the blockchain. There is no fishy thing that can happen without you actually seeing it on the blockchain. Perpetual protocol is, especially I mention it here because there is the concept of leverage trading, open and short positions, if you're aware of it. So basically you are betting against the volatility of an asset in the traditional market. So right now, most of the solutions right now that we have are using centralized exchanges because we need centralized market makers. But perpetual protocol is an example implementation of that. It can be done in a decentralized manner. Proper open and short positions can be created. Proper leverage trading can be done without a central entity if the blockchain becomes scalable. So perpetual protocol, I think it's on Polygon right now, and it's one of the most used, most popular implementation of leverage trading. Similarly, we have others like Curve Finance. Curve Finance is like again an exchange protocol, but it is all of it was initially designed to just deal with stable coins, but later upgraded to support different kind of assets. And basically anything that you can think of in the finance world right now. Here there is a protocol called Basket DAO. So there you can create your own strategies. There is one Enzyme Finance. Enzyme Finance, you can actually create your own strategies, create your own worlds, and other people can interact with you. So at some degree, you can actually design strategies if you understand the market. So there is like a whole lot of openings when it comes to finance. If we are actually able to leverage DeFi. So initially, what we discussed was DeFi, and it was dealing with a thing called fungible tokens. So firstly, what is the difference between fungible and non-fungible tokens? So fungible token is something, let's take an Indian rupee. So a 10 rupee note that I have and a 10 rupee note that another person have, both are just 10 rupees in value. So both stand at an equal stand. So there can be thousands of 10 rupees notes, and all of them will have the same value. Their value. So they are these type of tokens who have the same value, and they're not unique, are called the fungible tokens. Non-fungible tokens in a way are, take example of Mona Lisa. So if you take example of Mona Lisa, there is only one Mona Lisa, which is the original one, and there is not many replacements for it. So there is one Mona Lisa, there are no more replacement. It is just one unique non-fungible entity. And there can be several copies of Mona Lisa, but the original one just remains the same. So non-fungible token indicates an entity which is unique in nature, you can say. There's a chat. Okay, I will cover this question in the Q&A section, but yeah, sure. It's a bit of a finance question that is asked in the chat, so I will just cover it after the PPT. Just a call to the admin to keep a track of these questions. So some of the popular use cases of blockchain. So one is decentralized finance, as I already introduced you guys to, how we can lend money out, gain interest on stake money, do a lot of things. Another popular use case is using NFTs. So NFTs can act as a representation of ownership. So think of it as, for example, if I'm playing, let's say, PUBG. So I have a character and I have a level of, I'm not sure, I don't play, but if there is a level 100 if exists, then I have a player which is at level 100. And so this player is much more valuable than a player at a level 1. So if my character is represented using an NFT and I am the owner of that NFT, then this NFT is much more valuable than the level 1. So there are two different entities, they have different values. So this is one use case. If I want, I can sell that 100 level NFT to someone else. They can buy it and I can earn money off it. So I put in the effort to build that character. Now I can earn money on it. That is one use case. Second representation is ownership. So ownership and identity. So there is a new protocol called Lens protocol, which is recently introduced, which is like a social media. And what you are is represented using an NFT. Your social, there is an NFT which represents your social profile. So if I have an account on Lens protocol, I will have a NFT assigned to me with my name embedded in it. So that's like a real world implementation in which you are actually associating your social media account to an NFT and your access is using that NFT. Social tokens. So this is a relatively very recent concept which was introduced like a month or two back. So this is basically still a research-based concept, and the paper was recently released, and it talks about NFTs which are a representation of your identity, and the representation in this case refers to that these tokens cannot be just sent to anywhere or traded on the open market, but rather it will act as your representation, your KYC on the blockchain. So this is a very new concept which is introduced, but this is used for this concept is now being trying to be used in a lot of new projects that are upcoming, but in a different manner. There is no perfect decentralized solution available and live right now for soul-bounded NFTs. Another use cases for this will be something like artists. So if you are an artist, you have a bunch of paintings and you want to sell it on the market. So usually what you do, you draw a painting, you go around and you find a client, you give it to them. Here you can mint an NFT of that artwork and you can sell it on the open market. And not only can you sell it on the open market, there is a royalty standard that can be integrated. So if it is integrated, if the person who bought it from you sells it further, you will still get your cut. So as long as that thing exists and is traded, you are also earning money as the owner of it. So that's another use case. Similarly, there are instances of music collections, etc., getting launched. So I just wanted to cover this particular EIP, which was I think launched last year, which went live last year. So this is the EIP Fund 559, which is basically concerned about making transaction more efficient. So how it is doing is, before this EIP was implemented, the gas fees, which is the transaction fees you pay to the miner, was calculated by using an auction system. So whoever pays more gas gets their transaction processed first. Now how it is working is there is a base fee. Everybody has to pay the base fee. And above that, there is the, you can say, the tip that you can give to the miner to prioritize your transactions. And this base fee is actually getting burned. So the significance of burning an economy is the lower the supply of a particular asset, the higher the value. So in this case, what this EIP is actually doing is lowering the supply of Ethereum by burning it. And hence the value of Ethereum goes up over time because the supply decreases. So that is like a quick intro to EIP 1559. I really needed to introduce this one. Now let's just take a look at Solidity code. So here I have pulled up a simple ERC20 implementation. So ERC20 implementation is the representation of that Indian rupee that I talked about. Every 10 rupee note is still a 10 rupee note. So this is basically a code base that I will just show it to you guys how it is working. So this entire code is written in Solidity. So at line 9, what you see is an interface. So interface is nothing but the function definitions, storage definitions, and your events that are emitted. Events are logs on EVM blockchains. So this interface is basically defines the ERC20 standard. So just give me a moment. So EIP20 standard. This interface is basically a representation of this thing. And what this EIP is? EIP is nothing but Ethereum improvement proposals, in which we define standards and the way that the blockchain itself should move forward. So these are proposals for improvement of the entire network. So this was introduced a few years ago, and which basically tried to create these on-chain tokens. And this is basically the technical definitions of how this thing should look like and how the standard is defined. So what this interface is doing is basically dealing with these, basically defining this EIP structure. And later on, we have the contract itself, which inherits the interface and then does the implementation of it. Few things that are usually kept in mind when doing Solidity development is relying on data structures which are not that which don't have too much complexity. So for example, mapping, it's a O1, but if you use an array for just doing the same thing, it's O1. And this is really crucial, especially here, because if you don't, the gas fees is gonna just ruin the entire experience for the user. So here is a simple implementation of ERC20. So we inherited the interface on how it should look like. We defined the constructor, the name and symbol, the name. Later on, we have things like what is the token total supply, and then comes the balance of. So if I have this token, what is my balance? This will just simply return it. Then there are functions which deals with transferring of assets. So if I want to transfer my money to you or to someone else, I can use this function. There is a function called approve. Approve is used if I want some third person to send my money on their behalf. So I can approve them that yes, this person can send my money, and they will be able to do so. And similarly, allowance is basically how much money a third person can spend on my behalf. And then there is a bunch of functions like internal functions. So this is like for the implementation of the same thing. So I'll just demonstrate how it works. So what I do is, first of all, I created a new contract test, which inherited from ERC20. And basically, I have a mint function, which will mint whatever number of tokens I want to mint. This is just a mock, just for demonstration. We don't do it like it in production. So what I'll do is basically I'll deploy it here. So I can just name the token TSC, and token symbol also is TSC, no problem. My contract got deployed, and here I can see my contract. So what I will do is mint an arbitrary number of tokens to myself, because message.sender will be me. So this amount will be minted, amount of tokens will be minted to me. Yes, Shaurya?
Gas fee which you mentioned, is it being taken right now for deploying?
Can you speak again? Your voice is a bit low.
The gas fee which you mentioned, is it being used right now for deploying, or is it just for deploying to the production?
Gas?
Gas fee.
Oh, gas fee. Gas fee will always be used. So any transaction you do, you have to pay the gas fees. So contract deployment in itself is also a transaction.
So
So you will
technically,
be paying.
so this uses gas fee, the one which you just deployed.
Yes, yes. This
Okay.
thing that I did, this uses a gas fee. There must be a,
Okay. All right.
yeah.
Thank you.
So yeah, so and mint function also uses gas fee. Contract deployment also causes gas fee. The only thing that does not uses gas fee are view functions. So for example, there is the balance of. So this is a view function. It will not modify the state of the blockchain. So this, if I call, it will not use any gas fee. This is free. So I minted, I call this function mint on myself. So if I go, this is my address. So if I go and paste my address here, you will see that this is my number of tokens that I have. So now what can I do? I can call any of these functions. I can approve any third party to spend money on my behalf. I can transfer the money to someone else. So this is basically a demonstration. All of these, like this remix ID is very good for beginners if you want to learn. And these buttons which are in yellow color are basically the ones which will use gas fees, and the rest will not use gas fees because they are view only functions. So that's like an overview of what a fungible token, what a smart contract looks like. In production, obviously, this is converted into bytecode. There are a lot of things that you have to consider when writing these at a higher scale. For example, is the stack too deep? So EVM has a limit of 16 variables. So is your code inside of that? If not, you have to refactor it accordingly, and stuff like this happen. You will come across those things when you increase the scale of the project. This is a very basic ERC20 implementation. So this is an overview of what ERC20 looks like. I will just show you what the standard for EIP 721 looks like. So EIP 721, again, it's pretty similar in a way that you still have functions like transfer your NFT, approve your NFT, transfer from is used after approve, and yeah. But the only difference is here, rather than owning X number of tokens, you have a particular unique ID of an NFT assigned to yourself. So this is basically what an NFT actually looks like in the source code itself. And yeah, like that's pretty much it. There's the third standard called 1155, which is a multi-token standard. And there's basically, there is one contract which is handling a lot of different type of tokens. So it can be an ERC20, it can be an ERC721. Everything is represented using an ID inside of it. So you will always see this additional variable called ID passed inside all of the functions when it comes to EIP 1155. So these are like the three main token standards. And also one I wanted to introduce specially is the EIP 2981, which is the NFT royalty standard, because it specifically focuses on the use cases. And basically this is a standard used by all of the different exchanges available like OpenSea, Rarible, etc. And this is basically a standard which defines how to handle the royalty payments to the original artist. So there are some of the most widely used EIP standards. There are some complex ones, for example, Diamond architecture. So this is basically a code writing architecture. So I won't go into details of this thing, but this is a more advanced level thing actually in Solidity. So I'm not going to dig in, but it is basically a code writing pattern, which is among the recommended patterns to be written for projects with a very huge code bases. So these are, EIP does not exclusively mean something for the blockchain or something for Solidity or something for decentralized finance, but it can also be like how to write a code. So there are a lot of things covered. And I'm currently writing a list of blockchain resources. The team will ship it to you once I will add some new links to this also. This will help you. There will be some links related to like building secure smart contract. So for example, here this repo will teach you one of the 3 main security toolings that you will extensively use if you actually go into production level solidity writing. So things like static analyzer, fuzzer, symbolic executions, these things, like I don't think it will go beyond the scope of this workshop to get into this, but this is more on the security end. So if you are into auditing, or even if you are a general solidity developer, you need to understand these concepts, because once the code is deployed in main, you're kind of you cannot modify it further. Another thing that you might want to consider learning is about upgradability patterns. So upgradability is nothing but a contract which will be a new contract will be deployed, and you just change the implementation. So there's a contract which basically send your transactions to a particular contract, but if you want to upgrade it, you change the contract to which the transaction is being forwarded to. So this contract acts as a proxy, similar to how it works in Web 2. So that covers the upgradability part. And yeah, I think that covers most of the things. So thank you. I think we can open up the Q&A session now.
Yeah, so this question by Amit Goel: does deploying using testnet use CASP?
Let me just open the chat once. Yes, of course. So the thing will on the testnet would be whenever you go to a testnet. Let me just show you. So the thing is, you pay the gas fees in the native token of that particular blockchain. Can you guys see my MetaMask? I don't think so. Well, when you actually want to deploy on a particular testnet, you basically connect your wallet to that testnet, and here you can get free test tokens. So here, if you input your Ethereum address for Rinkibi, for example, which is a testnet, you will get test tokens on your Rinkibi account, and then you will pay the gas fees using those test tokens. Yeah. Does that answer?
How do these testnets make profit as they give tokens for free?
You have to understand testnets are zero value tokens. So the Ethereum you will get from this thing for free is not actually free because it is zero value. And you can basically stimulate real assets. For example, I talked about Uniswap. I talked about so any of these tokens, you will find their testnet implementation. So what you can do is actually, if you want to try out Uniswap, just get these free tokens from this faucet and go to the testnet version of Uniswap and just try out the protocol in general. You will not make any profit. Like, you can stimulate it, but even if you make profit, it will be zero value, because literally it's a testnet. It is for testing only. It is so it is mainly maintained by mostly voluntary organizations and using open source contributing organizations. So grants, etc., are used to maintain it. There is no incentive to actually do it. You are not actually earning anything. Okay, there is one question here. How does someone quantify the value of that one crypto coin? What are the factors involved in figuring the value out? Okay, you have to understand that all of these tokens, there is no particular way to fix the price. All of the price of a token depends upon the market. So for instance, let's say I have launched my own token, and initially I said, pay me, let's say 1 Ethereum and get 1,000 of these tokens. So initially, yes, you can say that the price, at some degree, I tried to set it to 1/1000 of Ethereum for one token. But later on, whatever the price is, whatever the value is, depends upon the market. For example, if you have actually heard about these things like, for example, the stock market is crashing, and things called whale dumping. This is basically someone trying to sell a lot of a particular asset in the market. So whenever you sell something, the value goes down. And whenever you want to buy something a lot, the value goes up, because now when you buy, there is a demand for it and someone is willing to pay you money for it. So you can slowly increase the price of that asset and the asset price goes up. Whenever you sell it, you just want to get rid of that asset and get another asset in return. So compared to that another asset, the value of this asset over time goes down. That's why if you have ever heard that, for example, if you take any billionaire or anyone, they don't actually have that money with them. And the reason is, if they actually try to convert it into actual money, because their money, for example, if you take Elon Musk, I'm not sure what his net worth is right now, assuming let's take 100 billion for simplicity. So 100, he doesn't actually have 100 billion. Like it happened in Twitter's buyout that he was trying to do. 44 billion he was claiming, but to actually get that much liquidity, he had to sell Tesla shares. And if he would have sold Tesla shares, the value of Tesla shares would have gone down. And if the value would have gone down, a lot of people would have been fired to adjust the company's profitability margin. So those kind of things comes into play when we talk about markets price of a particular coin. If that answers that question.
Yeah. That was a great explanation.
Okay. One thing like I would like to consider and mention is the need of blockchain in the first place. So since we are talking a little bit in the finance, I won't get too deep, but a small introduction would be like the reason this entire thing was created was because like I mentioned, the banks can have the custody of your assets, so they can do whatever they want. And there are a lot of chaos because these people have too much power in their hands. So I think it was in 1871 that it happened. So before 1871, I think it was 1871. Before 1871, the US dollar can be redeemed for gold. So this was the basis of the economy, that you have these fiat assets, and these fiat assets later on can be redeemed for a real asset called gold. That's how these assets used to derive their value from. But in 1871, the United States decided not to do it, and the pegging of US dollar to gold was removed, which resulted in an inflow of a large amount of money. So that was the problem which basically Bitcoin tried to solve back. So what happens is, since now there is no underlying asset to back the US dollar, the US government can pump in as much dollars as they want. So during the COVID crisis, they printed trillions of dollars, if you guys are aware of, and which actually, the more the money is in supply, again, the more the supply, the less the value. That's a basic economic concept. The more the supply of dollar came into the market, the lesser the value of the dollar become and higher the inflation happened. So what these things that you might be hearing in the news, if you're actually if you look into these things, that the prices of everything is going up. One is the Ukraine-Russia war, but another is the extreme pumping in the economy of fiat currency. So US was able to stabilize their economy at that particular moment, but now we are seeing the side effects throughout the world of it. So it was these type of issues, that there is no backing and anybody can pump as much money as they want, which created the actual issue in the first place. So that's why Bitcoin was introduced, because Bitcoin has an upper limit of 21 million. So it has a fixed supply, similar to how it used to be gold. So that is why Bitcoin is considered a digital gold, because it has a fixed supply, and after a particular time, there will be only 21 million Bitcoins. So that's how the supply demand for Bitcoin works. And because of the difficulty of actually mining a Bitcoin is pretty high, that's why it is another reason it's said to be gold, because the intrinsic value, a lot of people claim that Bitcoin has no intrinsic value, but if you think about it, the intrinsic value of gold comes from the fact that it is very hard to find. It is very hard to dig it out, and at the same point, it doesn't have a limited supply, because you don't know when you might find a new gold mine. But in Bitcoin, you are limited to 21 million by code, and the process of mining Bitcoin is very high energy consuming. So that's where that energy conversion to a financial currency is considered to be, is actually the basis of the intrinsic value of Bitcoin. So that's like a out of scope thing that I just wanted to mention. A little bit of finance, I won't go too deep into this. Blockchain work on writing spot contract. Yes, of course. So actually, there are a lot of things to consider when you're just writing smart contracts. So first of all, you need to understand finance. You need to understand what the blockchain technology is actually about. Why was it introduced? There are good resources online available. I will add some links later on for that also, if you guys are interested in the financial part. So firstly, why Bitcoin and blockchain is even needed in the first place? Why do we actually need decentralization? Things like these basic concepts. Writing smart contract actually comes a lot later because things are actually not that simple like I showed. This was a very basic example. So financial terms, understanding why the concept of ownership is actually very important and it is not available in today's world. Understanding those kind of things, understanding the code thing itself, like what is the meaning of scaling a blockchain in the first place. Like I am a solidity developer, but the things I've covered is not something I actually work on a daily basis. It is something I have to come across because I have to write smart contracts. So you cannot actually write good contracts if you don't know how the blockchain works. For example, if I take Polygon, so if you are actually deploying something on Polygon, most people just start using the smart contract after deployment, but you should wait at least 40 minutes. And that's like a thing most people don't know. Reason is they don't know understand the protocol. And the reasoning behind 40 minutes, it's actually 20, but safe side is 40. It's because after 20 minutes, Polygon sends a transaction to Ethereum mainnet and finalizes the organization of its own blockchain's block. So if before that finalization takes place, reorganization of blocks can take place, and which can cause issues for you. So these kind of things, you need to have a basic understanding of protocol also. You need to have a good understanding of your computer science fundamentals. Otherwise, the code that you will write, if it is not good in terms of complexity, you will have, if it is not good in terms of complexity, then the user is just going to pay a lot of money just in gas fees to process the transaction. So there are a lot of other things. Also, like smart contract writing in itself is very complicated because if not sure how many guys are you aware of, but there was a thing called decimals when I was talking about ERC20. So that decimals is there because we don't have decimals in Solidity right now, and we probably never will, because floating point numbers are a problem. So what we do is, if we want to represent 10.5, we do 10.5 into 10 to the power 18 or 10 to the power something, and then we send it to the blockchain. So you need to understand how to actually do addition, subtraction, multiplication, division also in this entire square. It is completely different than just doing it in the JavaScript world. So that's why the entry into DeFi as an engineer is considered to be very high. So that's why I personally suggest try to go on the NFT projects first, and as an intern positions first, rather than going for a full-time roles in something like DeFi, because it's probably going to be a very high barrier for you. So doesn't know that anyone can create a crypto. No, actually, because the just I'm answering the question that anybody can create their own cryptocurrency and enable the rise of meme coins. So of course there can be unlimited meme coins. Like I have a Rachit token live on mainnet on Polygon, so you can create as many as you want. But the thing is, the value of that currency is defined by the community. So for example, if we take, let's say, Shiba Inu, which is literally the shit coin, but the value was actually given by the community because they are sending the money. They are pumping the money into the asset, right? So if there is nobody to buy your asset, that asset is valueless. So it doesn't matter if you can deploy it or not. It's about if are the people willing to buy it or not. So it depends. Everything's value is determined by that. How do we transfer the ownership of NFT or tokens? So there was a transfer from function in the ERC 721 specification. You just call that function and you are good to go. Yes, there is no restriction on learning JavaScript for entering this space. Like if you're into protocol engineering, most of the protocol code is actually either written in Golang or in Rust. You are not actually using JS in any of those. If you are writing Solidity, so till now there were like frameworks like Hard and Truffle and a few more, and all of them were doing the testing part in the TypeScript and JavaScript environment. But there is a new framework called Foundry. If you don't want to learn JS, then just jump to Foundry and you can do everything, even testing in Solidity. So there are a lot of alternate options now. There's no such restriction of knowing JavaScript or TypeScript. So any other questions? To be very honest, it's your choice, but usually right before it was Truffle, which was considered industry standard. Today it is hard hat. And just to keep one thing you have to understand about computer science in general, and specifically any field which is not that old, like blockchain or augmented reality or anything, is that these industries are so new that anything can change anytime. So it might be that today everybody is using Solidity and year later Solidity doesn't exist. So if we are talking about right now, probably the go-to framework would be Hard Hat. And if we are talking about a year later, nobody knows. Like we don't even know if we will be using Solidity. Any other question?
That I think wraps it up. We don't have any more questions, I think.
Okay. Sure.
Yeah, I think I'll turn off the YouTube stream now.
Okay.
I think